We are going to see about the wedge experiment. As far as wedge experiment is concerned, the aim is to determine the thickness of the given wire or the thin sheet using this experiment. So the experiment consisting of a monochromatic source, a condensing lens, 45-degree inclination plate and wedge along with the traveling microscope. The first part is the 45-degree inclination plate may consisting of two sides. In one side both glasses get touch with each other while the other side is get open. So we have to allow the monochromatic light to fall at the open side of the 45-degree inclination plate. When the light is interacted at the wedge, so the wedge is nothing but the glass plate which will be inserted inside the 45-degree inclined plate. So in that side there are two sizes of specimens are available. One is said to be edge of contact and another one is the gap where the specimen is inserted. First of all, with the help of traveling microscope, we have to focus the interference pattern which was obtained from the wedge. How the interference pattern is observed? Actually, the light is traveled and it will be get reflected at the 45-degree plate and fall on the front surface of the wedge flip and get reflected. Remaining part of the light, it will be interfere into the wedge flip and get reflected from the back scattering glass plate. As a result, these two will form an interference pattern and finally set of fringes will be obtained at the outputs. The fringes can be viewed through the traveling microscope and hence the traveling microscope is focused vertically such that the vertical crosswire has to coincide any of the black interferent fringes which is very near to the edge of contact. Here the edge of contact is nothing but the rubber band. Therefore, I am going to focus now. You may able to visualize the bright and dark interferent fringes through the traveling microscope. I hope now you may able to visualize it. We will try to focus slowly. We are trying now. I hope now you can see some yellow color along with the alternative lines of black colors. That is nothing but the interferent fringes which will be getting from the output of the reflection from the 45-degree inclined glass plates. I hope now you can visualize this. So then what you have to do now, you have to find out the number of lines that will be crossing from the rubber band up to the specimen. We have to count for every 5 black fringes starting from the nearest black fringe as the nth one. Then we have to take the main scale reading and vernier scale reading that will be visible in the horizontal section, not in the vertical side. Sorry. So that will be available in the horizontal section. So after that I have to move this screw. Such that the number of black lines is shifted by 5 numbers now. Then I have to fix this. Then I have to take the reading. That is said to be n plus 5th range. So now I am doing. So now it is coincide at a particular black fringe. Now I am going to note down the reading. Here you can see an arrow mark. So the first line which will be very nearest to the arrow mark in the main scale is said to be your main scale reading. I hope it will be come around 7.4 something. That is your main scale reading. As you can see that there are 50 graduations are there in the upper parts. This is said to be vernier scale coincidence. Out of 50 graduation, any one of the line will be coincide the main scale and that has to be consider as your vernier scale coincidence reading. So for every 5 fringes, we have to note down the main scale reading as well as the vernier scale reading, from which the final values are calculated.